My name is Svetlana Isakova, and today I'm going to talk about the Kotlin programming language. I work at JetBrains, and at first I was developing the Kotlin compiler, but now I'm focused mostly on the conferences, on discussing Kotlin, and on writing the book about Kotlin. Some of you will. OK, so Kotlin programming language. Who tried it already? Oh, quite a few. That's great. How was it? Did you like it? Yeah, in general. That's OK. OK, so I'm going to give a mostly basic introduction talk about Kotlin, at least for the first part. But then we are going to cover, I would say, the most advanced feature of the Kotlin programming language. So I hope that even those who tried it will find something new for them. And I want to focus this talk on explaining these two words, modern and pragmatic. Because you can agree that nowadays these words are somehow become buzzwords. And everyone says, yes, we're modern, yes, there's pragmatic language, etc. But for us, they convey some important meaning. And I want to discuss that today. And that actually will explain why should you bother, or why could you bother about Kotlin if you have so many languages and if you have Java 8 now, etc. So let's start our journey. We'll start with more pragmatic things. And at first, Kotlin is a language from JetBrains. JetBrains is the creator of IntelliJ IDEA and several other IDEs for different languages and some team tools now as well. And JetBrains has a lot of expertise of writing compilers for different languages. So several years ago, JetBrains decided that they want to create their own programming language. And as it from tooling company, you can expect Kotlin to have a very good tooling. And that's indeed the case. If you try Kotlin compiler in Kotlin plugin in IntelliJ, you'll see that it actually supports almost everything that you used to have for Java language. Like all the intentions, inspections, refactorings, navigation, completion, smart completion, etc. And that's useful, that's convenient. Another important thing of Kotlin being pragmatic language, and that actually differs it from some other development languages, is that it can be very easily mixed with Java code. Kotlin code is compiled to Java bytecode, so it's no surprise that you can call Java code from Kotlin code. It's the same, as it's the same bytecode, that's very easy to call Java code. But what's interesting here is that you can go the other direction as well. So you can really mix Java code and Kotlin code in one project, and it will work. It will work without any additional difficulties. And what does that mean for you? If you have some Java application, Java project that you're developing, and you're, I don't know, fed up of Java's verbosity, you can actually continue developing it in Kotlin. You can add new code in Kotlin, and you will be able to add old code in Java, etc. So you don't want to rewrite everything, it will just work. And that's how we now work in JetBrains. For example, now partly new code in IntelliJ is written in Kotlin, in IntelliJ IDEA. And so it's impossible. IntelliJ IDEA is a huge product. So it's just impossible to rewrite everything. But when we add some new parts in it, in Kotlin, that works much better. One of the reasons why it is not so difficult to mix these two languages is that Kotlin doesn't have Kotlin SDK. There is no such thing as like another collections library. We use Java standard library. We use Java standard classes for collections, for example. We just provide a bunch of extensions for them. That means, on the one hand, that Kotlin has a rather small runtime, and it's especially important for Android development, for example. And on the other hand, it provides you very easy interoperability with Java code. So you do not have to convert, for example, list. When you use it, when your Java method returns list, you do not have to convert it to a special kind of Kotlin list, because it's the same. It's the same interface, slightly improved, but basically it's the same object at runtime. So no additional overhead is needed. It's just simple as that. Okay, so we've finished with this first part, pragmatic, already. And now we are going to talk about more complicated issues. What does the word modern mean? Because, you see, you will hardly call Java 8 a modern language, despite it has like Lambdas and all other cool features. But why? Why is it different? Why some people still say that, yes, we have Scala, we don't know to go away, we have some other modern languages, or we want to code in Kotlin as a modern languages compared to not like others. So what's the difference? And I will emphasize 3 items, 3 things that I find important. It is important that this thing is very common for all these modern languages. So it's not exclusive for Kotlin. If you look at Scala, at Swift, at other languages, you will find similar things. And when I say that, okay, modern is concise, safe, and expressive, actually, I do not mean it in general. I consider it with comparison to Java. So this modern language is more concise, more safe, and more expressive than Java. I know it's very hard after the dinner, but please, I hope you will enjoy some things. So, the first thing is concise. I will give you a very classical example that I would say every modern language shows you. So, there is this regular Java code. And everyone is got used to it, to write it, I hope, to generate all these getters and constructors. But what do we want here is to have a more concise way to express the same thing. And in Kotlin, now I want to use the tool, Java to Kotlin converter. We have a way to automatically convert Java code to Kotlin code. That's actually a nice way to start developing in Kotlin, for instance, because you can just, if you don't remember how to express something, you can just write it in Java, automatically convert it, and after that have your Kotlin code. So you use this converter, and you have something more concise, more simple to understand and read. And again, it's not exclusive for Kotlin. So all these modern languages have the similar concept. And even for Java, there are lots of frameworks that try to solve the same issue. We do not want to create verbosity, to create the code that just makes our understanding. So under the hood, this class is the same as the previous one. So for it, the constructor, to fields, the constructor, and to getters are generated. And you can use it from Java as it was written in Java, with getters, with calling the constructor, etc., etc. But in Kotlin, you can actually do more. You can add a very small keyword, data, with this class declaration, and it will generate a bunch of useful methods for you. For example, equals, hashcode, and toString. So it is data classes, and we usually do not compare different data classes by references. It is more convenient to compare them by data. And in Java, you have to generate it by hand, and you have to look at this code, to review it, to show it to your colleagues, etc. And in Kotlin, it's very easy to, write new 20 data classes, put them in one file, and say, hey, look at it, I've created new 20 data classes. So it's very easy to look through them all. Okay, one more example. And this will be at first Java code, and we'll convert it to Kotlin code, and then try to simplify the version, the Kotlin version. So we have description and a color. A color is some enum of colors. And we want to initialize these two variables depending on the weather. I don't know whether for you less than 5 degrees is cold, maybe it should be more, like 10. Or I don't know whether you find the weather outside hot, because for me it's really hot. But I'm from Russia, but maybe for you it should be like -30 or -10, and I would say like -5, well, like less than 5 or less than 20. But nevertheless, so now we just initialize two variables in Java. This code is trivial. What's wrong with it? So now let's convert it to Kotlin. Another way, just to copy-paste this function to Kotlin class. And you see the result is very similar. So it looks the same as the previous Java code. And this shows you an example of how you can write in Kotlin in very similar fashion to Java. So you can automatically convert Java code to Kotlin, and it will improve in some cases, but in others, like in the example above with the data classes, but in some cases it will look the same. But what can you do next? You can simplify this code to be written in a more Kotlin style. Let's look. At first, we have a small verbosity. We have to repeat this variable name for several times. Yes? We have to repeat the description name and the color name as well. And we would like to avoid it. And in Kotlin, you can't do that. In Kotlin, if is an expression that returns you a value. In this case, this if returns you a pair of values. And you can express it in Kotlin code. So you can say, if, like the first condition, if the weather is cold, return me a pair of values to initialize my two variables. In the other case, again, return me a pair of values, etc. So now it's a bit more understandable. It's a bit more easy to read. OK, so we've got rid of first verbosity. But now we can improve it even more. Let's look at these types. Why do we need them? Because in this context, it's clear what are the types of these variables. Kotlin is a statically typed language like Java. So in Kotlin, every expression, every variable has a type. However, you can omit these types if you want. There is a question? Oh, no, there is not a question. There is a, you see, the guy is there at the end. So we can omit these types when we do not need them, when the compiler can infer them for us. And again, it helps us to get rid of a lot of Java's verbosity. So you do not have to write all these types explicitly when they're clear from the context. So yes, the compiler can infer them for us. But again, we do not support dynamically typed parse yet. And in Kotlin, every expression has a type, so you have all the benefits of statically typed language. And again, this thing, the type of inference, the ability to infer types in your program, is not exclusive for Kotlin. So like Scala has the same feature. And there are even proposals to Java to add the ability to omit some types in the future versions of Java. So now it can be considered as a generally approved like the right thing to do, to simplify our code to omit some types when they're clear from the context. OK, but we can do even more. In Kotlin, there is a when construct that can be considered as an analog of switch, but that is more powerful. And in this case, you can use automatic conversion. IntelliJ suggests you to convert automatically if to when expression. And you can choose to do that. And OK, you have the result. So now it's just another syntax to check all the branches. to check if the condition is true. So it's not a big deal, but it's a bit more concise version than the first one. One more thing to improve. In Kotlin, there is another way to create pairs of objects. We will later in the talk look at what is this true. It's a function actually, and we'll discuss how it's declared and why can we use it. But now it's just our final version. So again, what we had at the first, our Java code, and at last our improved Kotlin code. So overall, it's not a big deal. So it was clear in the first, it's clear what's going on in our last version. But when you do this with every piece of your code, it turns out that you can, I don't know, like the size, you can decrease the size of your overall code like by 2 times or more. And that's how it actually works. So automatic conversion helps you, but then you can like use some more Kotlin features, rewrite the code in Kotlin style, and it improves readability even more. Maybe some questions? Yes?
In this Java example, we have description and colors, and these are fields, right?
The question is whether they are fields. The description and color, they are local variables in the function. So I admit that it was a function body. I'm sorry. So we can say, or maybe I had it in the beginning. So we can say we have a function like initialize our variables, and or they can be fields that actually doesn't matter. So you can. I see. You answer whether you can initialize. So yes, this you are asking whether you can initialize fields in the similar manner. Yeah, there is. You're right. This syntax works only for local variables. This this assignment. So if you have fields, you can still return the pair of objects, but you will have to say like the field per the first value and the second value. Yeah. Another question?
You have there a section called what about
Yeah. The question is about whether we have triple. Yes, we have in Kotlin triple. And I forgot to mention, we called the constructor pair, and we do not have new. So we do not have new keyword, so it was just a calling of a constructor. Yes?
What about end variable when you have?
If you have 4, 5, etc., try to use a class with some names for fields, for properties, because it's not a really good pattern to use pair, triple, etc. in your code, because it hides the meaning of these values.
So it's not a general mechanism?
No, we just, it's not, having pairs and triples, we do not have tuples, we dropped them at some point, so we just have these classes in standard library for pair and triple, and in general we suggest to use more descriptive names for your classes. So if you have some structure, you'd better to declare a class. But for illustrative properties, and sometimes it's really useful to return a pair of objects, for example. Yeah, like in this case, you do not need an extra structure for that. But in general, it's a better pattern to use some extra class. Yes? Yeah, everyone is very interested in comparison with Scala, and the thing is that maybe you've heard that in Scala there is a very powerful mechanism of pattern matching, and we do not have such a power. So we do not support the full mechanism of pattern matching, because actually it's quite complicated, and if someone else writes his own ways to unpattern, to custom ways to do this pattern that might be not easy to understand what's going on in Scala. So in Kotlin, we have much simpler concept. However, our approach works for majority of the cases, at least from our opinion. So if you're really a guy that really likes pattern matching, I don't know, in some functional languages, then you won't find the similar thing in Kotlin. But for majority of the cases when your patterns are very simple, you just compare the types and then access its properties, it works. So in general, Kotlin is much more easy than Scala. And if you are afraid of like whether you would be able to find your team members after writing a new project in Kotlin, that's not the case. Kotlin is rather easy to catch, to pick up, and to learn. Okay, now let's move on to our next topic. And this is another buzzword, safe. You remember this, a second one of this modern thing. So maybe you know this problem, and maybe you've heard about this term. And Sir Tony Hoare, who actually several decades ago invented null reference, he suggested this term, billion-dollar mistake, because actually we cannot estimate how much money we overall spend on fixing null pointer exceptions. So yes, it's null pointer exception problem, very popular nowadays. So what's the problem actually? Okay, we have an error, null pointer exception. Please give us more details. And there are no details, there are no additional details. It's just null pointer exception. So go ahead and fix it. And that might be a complicated thing if you have just only I don't know, jar files of your project, if you do not have access to source code, or null pointer exception happened on a line where it could be happened in several dereferences and so on. So it might be not very tricky, not very easy. And a modern approach is to fix it when we write code, not when we execute code. So we have these exceptions at runtime, but we want to prevent them at the stage when we write our code. And again, this approach is not exclusive for Kotlin. It's common for all modern languages. And for example, what solution to this problem is suggested in Java 8 and Scala? Option types. Yes, you're right. So there are like different solutions to this that all have this in common, to try to prevent these errors, to avoid fixing them later. And Kotlin has another solution, nullable types. Who've heard about nullable types before? Okay, so I can cover, not everyone, so I can cover them. So in Kotlin, we have two different kinds of types. If you declare a variable of a regular type, string, you cannot store null there. It's forbidden. So the compiler won't compile this code. However, if you want to be able to store null in the variable, you should declare it as having a non-null type. Oh, I'm sorry, of nullable types. So string is non-null type, string question mark is nullable type. And in a nullable type, you can't store null reference. Or you can store non-null references, of course. And then the compiler behaves differently when you try to access these variables. If it's non-nullable type, should it be compiled? This code, yes, of course, because it's just the reference, and the compiler guarantees that S1 is not null. But what about the second case? When we try to dereference an instance of nullable type, what do you think? No, the compiler forbids us to write this code. So you cannot just dereference it, because in this case, you can have null pointer exception, and we try to prevent it. So the Kotlin compiler suggests you the ways how to dereference this variable in other ways. At first, you can simply check. This is what we do in Java, I suppose, all the time. So if you check whether the variable is not null, After that, you can easily dereference it, and that will be compiled. But this pattern can be expressed better. Again, IntelliJ helps us here, and if you write this code, IntelliJ suggests you to replace it with safe access expression. Let's do that. Oh yeah, so it's simply like this. It's not a Kotlin invention. I would say it was stolen, or once they advised me to say the word borrowed from the Groovy language. And what does it mean? It says that if S is null, do nothing. If it's not null, call the function. If you want to return it, to return the result, to assign it to a variable, it works the same. So actually, it's another way to write the first if. So if it's not null, return me length, otherwise null. It's just the more concise way. If you want, and what is the type? The type will be nullable. Yes, the type of the result. If we can return null, the type of the result is nullable, for sure. I will going to show you how to do that, but if you try to write int here, the code won't compile, because you cannot assign something nullable to something non-nullable, non-null. So you can't say just int here. It won't compile. If you want to use 0 as a default value, you can do it by providing default value. So this operator, it's called Elvis operator, strangely. It says if this is null, then return null as a result. Return 0 as a result, sorry. So again, it's not our invention. It's used in other different languages like Groovy. And it turns out it's very convenient, for example, because you can use safe access in several dereference calls in a line. And that will save you lots of if checks, etc. So this small pattern turns out to be like it decreases the size of your code even more. Just this simple thing. Speaking about what we miss in Java still. Okay, and in this case, for sure, the result type, the type of the result is not null, it's just int. So you can dereference it if you want. Yes? From Java perspective, it would be regular Java. So you can, you continue to write your Java code as you used to have. So if you have mixed Java to Kotlin code, unless you annotate your code, I will explain it a bit later, you will have all the problems, all the Java problems with you. So I will comment it like a couple of slides later. Yes, it's not optional. It's just it's a regular string for Java. So Java sees both nullable string and non-null string as a regular string. More details into slides. Please wait, just 2 slides. Okay, one more way to I see you in 2 slides, just in case. Maybe you want to ask something similar. So another way to cope with these nullable values is if you check explicitly, it's a common pattern in Java, I suppose. You just check whether your variable is null, and if it's null, then you, in this case, fail. So this fail function will throw an exception, or you can return. And the Kotlin compiler is smart, so it notices that check and allows you to dereference it easily. And one last way, if you really want null pointer exception, I don't know, you love null pointer exceptions and you can't live without them. So you can you can say, yes, please throw null pointer exception. I'm sure I'm right. I'm sure this variable cannot be null. And in this case, it throws null. But yeah, if it's null, it's more detailed message than regular one, but you can do this easily. And for example, this concept of nullable types, it's the similar concept to the Swift language. Maybe you've heard of it. And now we can say, yes, we know how nullable types work in Swift as well. And the only difference is that in Swift language, they use one exclamation mark for the reference, for this null pointer exception thing. And in Kotlin, we use two just to say, please do not use it. Try to avoid these exclamation marks in your code. It's explicit, but it's better to use safer ways to the reference. OK, now what is going on under the hood? And that will explain how it is looked from Java, how we can use it from Java as well. Under the hood, this nullability is implemented using annotations. So if your method returns nullable type, Java sees it as annotated with a nullable annotation. If it's not null, it sees it with non-null annotations. These annotations exist for, I don't know, quite a long time. So, for example, in JetBrains, for our local products, we use these annotations for several years now. And some additional libraries provide the similar annotations for Java, so you can use them as well. And at first, we wanted to, there is no additional overhead, and it's not option types. So Java looks it as annotated types, and that means that if you use Java, like if you have mixed Java Kotlin code, for example, in IntelliJ, and you use Kotlin code from Java, Java will allow you to, Java compiler will allow you to dereference nullable type. However, IntelliJ will warn you that you try to dereference something is nullable. So IntelliJ supports several kinds of such annotations as warnings for Java code. And even if you want, I don't know, use Kotlin for some strange reasons, why not? You can still use this annotation in the Java code. It will help you avoid lots of problems that you have with nullability. So this approach in general with annotation works for Java code as well. So there was questions somewhere, yeah. Say it again? Can you explain how this interacts with boxing, out-boxing? Because so for most, the question is what's going on with boxing and out-boxing, because in Java we have primitive types and wrappers, and in Kotlin we have int and int question mark. So for majority of the cases, int is primitive int, and int question mark is the wrapper. I say for majority of the cases because if you use, for example, list of int values, it can't be list of primitive types. And it works like it's Java, it will be a list of generics. But in simple cases, in majority of general cases, it would be direct correspondence. More questions? Yeah? If I try to assign non-nullable to... the question is whether I can add nullable and non-null value. The result is that the code won't compile. Because you just can't, because it's the danger of null pointer exception as well, so you have to check it explicitly every time. One last topic. How much time? Oh, there is some time still. And this is, I would say, the most non-trivial thing about being more expressive. It's very difficult actually to say, like someone comes to me and asks, so what do you miss in Java language? So why not, like we all, what features do you miss or something? And in general, it's not very easy to answer that question because there are lots of them. And the most important thing is expressiveness of the language. And I would say that's a bit of a philosophical question. Which languages do we call expressive enough for our purposes? And I would say that is about something that help us read better code as a result in the end. So yeah, something that if the language help us avoid repetition, just let us write better, more beautiful code, or even something that looks like very specific to your environment, that looks like DSL, but it's actually just a library in your language, that probably the language is more expressive. And in this topic, I want to cover 3 features of the Kotlin language. And the last one, I would say, is the most difficult feature in the Kotlin language overall. So that's an important thing, because if even in introductory talk I tried to explain it, and I hope that's possible to some extent, that overall means that Kotlin is not very difficult. So there are no really secret deep holes, etc. So you can grasp it in several days, I suppose. So at first I want to cover the feature called extension functions. Who thinks he might know what I'm talking about? And actually it's the same feature as we have in C#. So again, it's not a Kotlin invention. Okay. The second one is Lambdas. Who knows about Lambdas? Who knows everything about Lambdas? Okay, I think everyone knows everything about Lambdas. Because, I don't know, I think in every talk about Java nowadays, they mention Lambdas and so on. And the last one will be Lambdas with receiver. And it is the one thing that was truly invented in Kotlin. Finally, we have at least something that we haven't stolen from any other nice, beautiful languages. Okay, let's start with extension functions. Extension function is a mechanism that allows you to extend the functionality of some class. So, for example, we have standard Java string class, and we do not have our own string class in Kotlin. We use the standard Java one. However, we miss several of useful methods in it. And I suppose every project uses some sort of string utils library, or either they're written by their own, or some other library that extend the functionality of strings. So, for example, we miss this last char function. In Kotlin, we can add it as an extension function, and there is the syntax. The fun keyword defines a new function in Kotlin, so it's indeed lots of fun. And in the body of this method, you can actually use equal sign if your function returns a simple expression, like in this case. You do not have to use square brackets and write return. And in this case, this reference refers to string receiver. I think that should be clear. So it's just another syntax to access string in the function body. And as a regular for this reference, you can omit it, and you'll have more concise way to write the same thing. Okay, so now that's clear, but why would we do that? What are the benefits? Actually, this extension function can be called as a regular method of the class. So you do not have to say like string utils dot last char my string, etc. This code looks much easier to understand, much more simple. And what's more, this function is visible in completion. So how do you usually, I don't know, try to find the necessary method? I suppose just call completion or smart completion and just investigate what methods do we have in our class. And this completion also suggests you all the extension functions. So it's much easier now to find what you really need, a function or string. In Kotlin, you have to import this extension function explicitly if it's located in other package, in other module, etc. So you just cannot use all the extensions declared in your project everywhere. It will be a mess. So you have to import it explicitly, and after that you can use them. So I've told you that Kotlin code can be easily mixed with Java code. I repeated overall. And now you must ask, okay, how will I call this extension function from Java? So I told you that's very easy to call Kotlin code from Java code. So why? So here is an example, and there is a question how to do that. So let's say we have this extension function declared in the Kotlin file, and in Java code, you call it as a regular util method in some class. So if you would declare this last char function in Java, you would put it in some, I don't know, special util class and make this function static, taking string as a first argument. And that's exactly what's happening under the hood. That's why you can call it from Java as it looks like Java. And you can add static import, and again, it looks like a regular Java code. But from Kotlin code, it's more concise, and you can use it as a member. No. The question is whether we support carrying. It's a functional programming thing that we can, return a function that will take another argument later. So we do not support some very sophisticated features from functional programming, like pattern matching, as I mentioned before, or carrying, to make things more simple. And and under the hood, you cannot very effectively implement that on JVM. That's another point. So you have to keep that in mind all the time that you use it. That's why we do not support very deep functional concepts. So maybe some more questions about extension functions. No, you cannot use. No, you cannot use. You have to declare a bunch of extensions in Kotlin that will just delegate to your function. So you have to write this library one time for your library and then use it all the time. But it won't be done automatically. Because in general, it's not clear where should it be an extension or not. So maybe later we'll support something like annotations. But for now, you have to provide the declarations. And now I have a question to you. To wake up someone who is deeply in sleep after the dinner. What do you think? Is it possible to call a private member of string in the body of extension function? Who says that it's possible? My left hand. Who thinks that's not possible? And my right hand is right. You see, it's not possible. Because actually, under the hood, this extension function is a regular static function. So is it possible to call private member of string from a static function in Java in another class? It's not. Yes, only by reflection or some special needs. But by default, it's not. In general, it's not possible. So it's, this extension function is not a way to somehow change JVM classes that exist. No, it's just a convenient way to express the concept that we all have worked with, like for many years, this util function in a static util functions in some class, but just declare them in a more nice fashion and use them again in a more nice fashion. More questions about extensions, because now we are going to move to Lambdas. I forgot. Two. I promised to say a couple of words about these two functions. And in Kotlin, there is this infix keyword that you can write in front of the function. And this infix keyword will allow you to call this function in an infix form. So you can call these two functions like this, all like this, so without dot and parentheses. And why is called to, why the to function returns you pair? It's a very nice way to create a map. You can create, this way you create a map of, like you provide your arguments as pairs of values. And for those of you who are afraid of Java generics, you can ignore types for now, but the general thing is that this function just returns you a pair. So that's not a big deal. That's just another way to create a pair of objects. Yes? Yeah, there is a question whether in Kotlin we can overload operators, and the answer is yes. You can write nice things like date plus date, or date plus time period, etc. in your code. However, we do not have the same mess as in Scala, because in Kotlin, the number of operators that you can overload is limited. It's limited to the standard ones. So you cannot declare everything that you can possibly imagine and call it a library. That would be rather difficult to program in. So yes, there is operator overloading, but in a more general form. Finally, lambdas. And so I suppose that you fed up with lambdas, so I won't devote too much time for them. But in general, the thing that we must know about them is that you can use lambda instead of any anonymous class with one method that you will use that you would use in Java code. So, for instance, this add action listener expects a listener. Here is an example. An action listener that have to override only one method. So that's a typical Java code prior to Java 8, actually. So in Java 8 and in Kotlin, you can pass lambda instead. In Kotlin, lambda always goes in curly brackets. So it's very easy and when you see these curly brackets, it's probably a lambda. And you see that you can omit the parentheses here. So actually, lambda is a first argument, as above, but without the parentheses around it. So here, E is the first argument. You see, again, we can omit type. Kotlin infers the types, so you can omit the type of expected lambda parameter here. And actually, as we do not use this lambda argument inside the body of the lambda, you can omit it at all. So here we have this concise syntax. I would say that shouldn't surprise you, because now you got used to using these lambdas instead of anonymous classes. And we also support this functional programming style of working with collections. So you can use lambdas to manipulate collections in Kotlin. So for example, we have this employee class that for now contains only two fields, city and age. And we are interested, so for example, JetBrains has an office in Prague. So we can ask what is the average age of employees in Prague. And lambdas and functions working with lambdas provide us a nice way to deal with this question. So you see that we are not in Java 8, so we do not have to convert collection to stream any longer. You can just call filter directly and provide this lambdas. The full form is, okay, by employee, give me whether it lives in the city or not. And after that, you can transform this collection of employees to collection of ages. And by providing an age of each employee, and then you call average function. And in Java 8, you have to convert collections to streams. However, in Kotlin, it's not the case. You don't have to do that. You just call these methods. And as you can guess, actually, these all are extension functions. So we see that extension functions mechanism is quite powerful. So we provide extensions for regular operations on Java collection classes. So that's why we can use just Java collections in our code. We do not have our collection libraries for simplicity and for easy interoperability. But you can use all these modern features. And what's more, it works not only in Java 8, but in Java 7, 6, etc. So, for example, it works for Android, and Android people are very happy about that. So you do not have to convert it. Yes?
They are already in language.
Yes, so the question is where do we have this filter map and average? They are in the Kotlin's, when I tell that Kotlin doesn't have its own standard library, I somehow, not cheating, but it's not, so I mean that it's not, it doesn't have its own like re-implementing of collection libraries. However, it provides you a bunch of extensions. So Kotlin's standard library is just a bunch of extensions like filter map and average to Java standard collections classes, and so just extensions to Java standard library. What if one element of this list is null? You see, it's declared as list employee without question mark. That means that it should fail on that moment when you try to put null there, if it's pure Kotlin code. I want to, talking about nullability, what I missed is that in Kotlin, when you use Java code, it's, if it's not annotated, you use it as it were like Java code without knowing whether it's nullable or not null. And you have to check everything explicitly by your own. But in this case, if its list employee comes from Kotlin, then it just cannot contain null. If it comes from Java and you try to do something with it, you have to fail with an assert, something like types says that it's not null, but the element is null. So when you work in Java, you fail early, and then you would fail in Java by its own. I'm not sure I haven't, yes, confusing? No, we do not map them for Stream API. They are implemented by their own in the Kotlin standard library. So we have implementations of filter map and average. I would say they are not very difficult. It's clear what's going on there. So we provide these extensions with the implementation. And you see that works with prior version to Java 8. It works for Java 6 and 7 as well. So we have to provide some implementations for them. We do not always have this Java 8 backend. Yes? No, it's compared to Java streams. This version is not lazy iterating, it's eager. However, you can do lazy iteration in Kotlin as well. If you have Java 8, you can use streams, or you can use so-called sequences from Java collection library. So by default, they are this eager iteration. And don't go deep into details. These lambdas actually are inlined, so and these functions are inlined, and you will have almost the same code as you would write by hand. So it's crucial for prior versions of Java. Okay, one more question and we will move on. Yes, if you know Java 8, so the question is whether it's compatible, is Kotlin lambdas are compatible with Java 8 lambdas. And the thing is that in Java 8, you can pass lambda everywhere when you expect function type, so-called function type. And in Kotlin, it's also the case. So it works with the same mechanism. And when you, so you do not just pass abstract lambdas, you pass instances of some interfaces. So, for example, like function, like interface function. And in Kotlin, they are instances of the same interfaces. So overall, yes, they are compatible because they are just implement the same interfaces. Say it again? Whether Kotlin Lambdas are serializable or not, I don't think so. I don't think so, but I can't be sure, so I have to check that. Yes? I wouldn't say so because it's just a piece of code, so it would be a tough question. So we can discuss it later because we have to go. Okay, let's, what is, I forget what was the time. What? 10 minutes. Okay, 10 minutes more. Thank you. What? Say it again? Okay, so we've already finished. Very good, because no one notified me, actually. So I think I will go very briefly to the last thing of my presentation. If you are very interested in this thing, please go to our JetBrains booth. JetBrains booth will be very happy to explain it. And I will just finish with last slides of my talk. And overall, I've showed you some features of the language. We've missed this most difficult one, these lambdas with receivers. But one of the features that shows that Kotlin is good for writing decels. And one of the examples, of the recent example, is that in Gradle, now it's work in progress, but very soon you'll be able to write scripts and plugins in Kotlin. So Gradle, you would be able to write Gradle scripts in Kotlin, and it is, as it's statically typed language, you will have all this static typing support for free. And last references, last links. So it's the site of the Kotlin. You can look through it, you will find something interesting. If you want to try to learn, you can use Kotlin koans. So we have them online or in some special educational edition plugin of IntelliJ. And it's just 42 tasks to accomplish, and after that you'll be able to say something like, yes, I know how to code in Kotlin. Maybe you've seen it somewhere. You can tweet it after finishing all the levels of Kotlin koans. And another resource to learn Kotlin is the book. It's almost finished, so now we have around 11 chapters out of 12. So we are going to finish it soon. And you can already read it by me, a program of Manning. And we have rather active community in Slack. So you can join if you want. And thank you, and have a nice Kotlin.